This lesson is on scale factor. Our goal is that you understand and apply the effect of a scale factor K on length, area, and volume is to multiply each by K, K squared, and K cubed, respectively. The scale factor is the K. We use K on length because length is one-dimensional. So that's why it's K. It is only the length. Area has a length and a width. So that is two-dimensional. So then we use K squared. But K squared is not the scale factor. The scale factor is K. We use K cubed for volume because volume is three-dimensional. It has a length, a width, and depth. A scale factor K is the ratio between the scale of a given original object, R, and a new object, which we call R prime. So it's pretty similar, it's just a different size. K is equal to R prime, so the new object, divided by R, which is the original object. So if we are doing an enlargement, we are going to have a number greater than 1 because R prime is going to be bigger. We're enlarging it. If we're doing a shrinkage, we're going to have a fraction because our R prime is going to be less than our R. So our numerator is less than our denominator, which causes a fraction. In this, I have a picture and I'm enlarging the picture. And so my width here is 3 units and it becomes 9 units. So going by the length, which is in this case the width, I have 9 units divided by 3 units, which gives me 3. The units cancel. There are no units with the K. It's not a form of measurement, it's a multiplicand. So K is equal to 3 because if I take 3 times 3, I get 9. Now, if I'm looking at my area for my small original picture is length times width, which is 3 times 2. So I get area is 6 units squared. And my area for my enlargement picture is length times width again. So 9 units times 6 units gives me 54 units squared. Now if I'm taking my enlargement of my area, I have 54 units squared, and I'm dividing by 6 units squared. That gives me 9 units squared. Remember, K was 3? Well, that makes sense because 3 squared is 3 times 3, which is 9. And that's when I'm talking about area. It's squared. When I'm talking about volume, I have 381 inches cubed is the volume of my original soccer ball. I'm shrinking the soccer ball. When I'm shrinking it, I'm going to be multiplying by a fraction or decimal, a number between 0 and 1. So I'm coming up with a volume of 14 inches cubed. If I take K cubed, it's got to equal my V prime, which is my new volume, divided by my original volume. So that's 14 inches cubed divided by 381 inches cubed. I end up with approximately 37 thousandths. K cubed is 37 thousandths. Remember, you can use a calculator on this. When I take the cube root of that, I end up with 33/100. Written as a fraction is 33/100, and when I reduce, I get approximately 1/3. Which, if I check this, that makes sense because my radius is a length. It's one-dimensional. My original is 4.5 inches, and my new image, my radius, is 1.5 inches. So I have 1.5 inches divided by 4.5 inches. The inches cancel out, and 1.5 divided by 4.5 reduces to 1/3. If an enlargement of a rectangle that has a length of 24 centimeters and the original rectangle has a length of 3 centimeters, what is the number that you would multiply the area of the original rectangle to find the area of the enlarged rectangle? So K is my R prime divided by R, my new region divided by my original region. K is the scale factor. R is the original figure and R prime is the new figure. So I have K equals 24 centimeters is my enlargement, my new figure, divided by 3 centimeters, and I'm talking about the length, so it's 8. 8 is the scale factor, but I don't multiply by 8 to find out my area. Area is two-dimensional, so the number needed to multiply the area of the original rectangle to find my enlargement area is going to be 8 squared, which is 64. 8 times 8. If the area of the original triangle is 28 inches squared and the area of the triangle shrunk is 7 inches squared, what is the scale factor? Well, my original is 28 inches squared and my new one is 7 inches squared, and I'm looking for K. K squared in this one is R prime divided by R because I'm talking about area, so it's K squared. K squared would be 7 inches squared divided by 28 inches squared, which reduces to 1/4. 7 goes into 28 4 times. The square root of 1/4, what times itself gives me 1/4, is 1/2. The scale factor is 1/2. K would be 1/2. A spherical hot air balloon has a volume of 125 meters cubed, and it loses air. What is the new volume of the hot air balloon if the scale factor is 1/5? The volume is three-dimensional. So R prime equals K cubed times R. R prime is equal to 1/5 the scale factor cubed times 125 meters cubed, which is my original. 5 times 5 is 25, and 25 times 5 is 125. So my R prime is 1 divided by 125 times 125 meters cubed. So these 125s cancel out, and I'm left with 1 meter cubed. 1 meter cubed is the volume of my hot air balloon. The new volume of the hot air balloon is 1 meter cubed. Must have gone twice. Okay, the new image is R prime, and the original image is R. K is the scale factor. If K is bigger than 1, it is an enlargement. If K is between 0 and 1, a fraction or decimal, it is a shrinkage. The length, r prime equals k times r. When I'm looking for area, it's r prime equals k squared times r. But this is area for the r's. When I'm looking for volume, it's r prime is equal to k cubed times r.